Okay, first I'm discussing page 4. So this one is page 4. The super tanker of mass 4 exponent 8 cruising at an initial speed. So that's a starting speed 4.5. The mass is there and it takes 1 hour to come to rest. So this is a duration. 1 hour means 60 minutes multiplied by 62, you will convert into second. So 3600 second. The final, because it comes to rest, so final speed is 0. Deceleration, which is v minus u over t. What is the v? The final speed is 0, initial speed is 4.5, and the time interval is 3600. The distance traveled, so distance traveled to as, the distance travel you using equation of motion to as is equals to v square minus u square. So we have two acceleration we will have from the last part. We can use that acceleration. Final velocity is 0 and initial velocity is 4.5 square. So we can find the distance traveled by substituting the values. The next part, sketch using the axis below a distance time graph represent the motion of the tanker until it stopped. So distance time graph, and what we have to show? We have to show a deceleration. So deceleration means speed is decreasing. So if a speed is decreasing, it means this, for a distance time graph, the slope represent speed, and deceleration means speed should decrease. So if speed is decreasing, it means the slope should also decrease. So you can see the graph. This is a graph for decreasing speed. Angle is, slope is decreasing, it means the speed is also decreasing. Then question, page 6, question 1b. Page 6, question 1b. Yes, you can mention the axis as the values are there. You can have the distance here. Like example, the distance travel was, when you calculate the distance travel, it was 8.1 exponent 3. So 8.1 exponent 3 is the maximum distance, and the time, how much time it took to complete the journey, 3600, and you can complete your graph. Then page 6, question 1b. Estimate the maximum distance between the athlete. So estimation is there. As they mentioned, the distance time graph for the two runners A and B in a 100-meter race, and explain how the graph shows athlete B is accelerating because the slope is increasing. It means the speed is increasing. He is accelerating. Where for athlete A, he's moving or running with a constant speed. So maximum distance between the athletes. How we can estimate this maximum distance? As you can see, so the distance, The graph is there. So what we can do, we can work out, this is a simple estimation is there, like as you can see, which position, this is a distance time graph, so which position we have the greatest gap between the two graph lines. So you can see in this region we have the maximum gap or distance between the two. So that will be the maximum distance between the two. And what is the estimation? This is just an estimation, like this value, each is representing 4. So this is 28. And this one is approximately 56, or you can say uh, 54, because it is between. So just the difference between the 54 minus 28, that will be the estimated distance between the maximum distance. Because maximum distance, this is a distance time graph. So you can see, if I take 2 seconds, the time 2 seconds, that's a distance between them. If I take time 4 seconds, that's a distance between them. If it take a time 6 seconds or in between even, basically I have to estimate like which position they have the maximum gap between them. That is a maximum distance between them. So we can just estimate and get the answer. Is it clear how it is done? The maximum distance between the two athletes. Then last page, question 5, part B. Last page, question 5, part B. In practice, the acceleration is unlikely to constant state a reason and explain effect that will have on a minimum length of runway required. Because what happened, like for aircrafts, for rockets, they're using fuel. So their mass is not kept constant. Say, and as well as air resistance also, as it is increasing the speed, the air resistance is also increased. So as the aircraft accelerate from rest and it with a speed of 82 meter per second, the engine provide a constant thrust. So engine is providing this constant thrust, but in reality what happened, the thrust is a force which is driving the object. So as the speed is increasing, air resistance is also increased, and air resistance oppose the motion. So air resistance is opposing the motion. So what happened to, so as air resistance is opposing the motion, so what happened to the resultant force? The resultant force will decrease. If resultant force is decreasing, acceleration will also decrease. So in practical, acceleration will not be constant if the driving forces or the thrust is constant. So you can see the last part. As the speed is increasing, the air resistance is also increasing. So as air resistance increasing, resultant force is decreasing. So to reach 82 meter per second, we need a longer runway, because how a plane is taking off, it started from rest and it reaches a speed of 82 meter per second. Once it reaches 82 meter per second, it take off. But because air resistance is acting, so acceleration decrease or change in velocity decrease. So it will take longer time to reach 82 meter per second. So as it will take longer time to reach 82 meter per second due to smaller acceleration, so we need a longer runway for that. Is it clear? This was question number, last page, page 7, 5B. Is it clear, this question? Because what happened, you have this formula, resultant force is equals to ma. As the aircraft is taking off, the driving force is constant. But as the speed increase, the air resistance also increase. If air resistance increase, because the two forces are in opposite direction, so resultant force decrease, which reduce the acceleration. So if acceleration is small, means it will take longer time or cover greater distance to reach 82 meter per second. Any other question in this exercise? An egg of mass 5.8 exponent minus 2 is dropped from a height of 1.5 meter. Assume air resistance, loss in potential energy. So potential energy is mgh. Kinetic energy, the potential energy will be equal to kinetic energy if there is no loss of energy. Speed just before impact, so potential equal to kinetic, so 0.5 mv square is equals to mgh. So using this we can find the momentum. Momentum is a product of mass and velocity. So we'll multiply the mass with the velocity which we calculated. On hitting a floor, the egg brought to rest in 0.01. Calculate the magnitude of average decelerating force. So F is equals to ma. First we'll get the acceleration. The initial velocity is there, final is 0. And divided by time, we'll get acceleration. Acceleration multiplied by 4 mass, we'll get the force. Now they mention the egg is now placed in a container that crumple on impact, means that will deform. Explain why this type of a container makes it far less likely the egg will break. Because if something crumple, it means it is absorbing energy. So when it is absorbing energy, less energy is transferred to the egg, or so less energy or small force experience. Like what happened as this egg hit, it crumple, means this will deform. So as it will deform, it is absorbing energy, so egg will experience a smaller force. So this is related to momentum and impact, you can see. So it will take a longer time. So, and this is related to the, if you remember O levels, you studied in O levels, the impulse is equals to the change in momentum, or F is equals to rate of change in momentum mv minus mu over t. So as it will take, as the container crumple on impact, so it will take more time to stop the egg. So if it will take more time to stop the egg will experience smaller force, so less likely it will break. If it was a hard surface, rigid surface, the moment egg hits the ground, hit the surface, the container, because it does not deform, so in a short time the object will stop. So if object stop in a short time, it will experience maximum force. Is it clear? Any other question in this exercise? Yeah, what's the question, Abdul Munir? You should submit the homework as well. Page 1, question 7C. Yeah, this is the same question I was discussing. The question is, the egg is now placed in a container that crumple on impact. So if a container crumple on impact, means the container is deformed. So if anything deformed, so what will happen to the egg as it will hit the base? This egg will take more time to stop. As it will take more time to stop, it will experience smaller force. We have the formula for F is equals to ma, or we can also say acceleration is v minus u over t. So you can see that the relation between the time and the force is inverse. If object take more time to stop, it will experience less force. So this egg, when it will hit the base, it will take longer time to stop, so it will experience smaller force. Today's topic is important topic. You will find every year question related to this topic, which is called projectile motion. What is a projectile motion? A projectile motion is basically a two-dimension motion, is known as a projectile motion. Like example, if you kick a soccer ball or you throw a ball, so what path that object will follow? If you throw an object, you throw a stone, so the trajectory, the path which it will take, this will be the trajectory. This motion is known as a projectile motion. Why we call this as a projectile motion? Because it is having two dimension, like two components of motion are there. One is a horizontal, because it is moving, it is covering a horizontal distance, that's why horizontal motion is there. Another one is vertical, because it is moving up, so it will have vertical. What are our assumption? What are our assumption? We assume air resistance does not affect this motion. This is our assumption. And the acceleration is due to gravity. So when we say air resistance does not affect the motion, what is the meaning? It means the horizontal component remains same. So if air resistance does not affect the motion, it means there is no acceleration or change in speed in horizontal component. Or we can say the horizontal component remains same throughout the motion. Example, you launch a projectile which is having two motion, the horizontal and vertical. So if the original horizontal is say 30 meter per second, so the horizontal velocity, the horizontal component at any point will remain same 30 meter per second. So throughout the motion, the horizontal component will not change. So there is no acceleration in x-axis for a projectile motion. In practical, there will be acceleration, but our assumption, because there is no air resistance, so horizontal velocity remain same. And the gravity affect the vertical component So it will decelerate as it will go up and accelerate as it will move down, and the acceleration or deceleration will be due to gravity, which is 9.8 meter per second square. So acceleration and deceleration will be same. That's, but if it is going up, the vertical velocity will decrease. If it is coming down, the vertical velocity will increase. But I'm taking, just for explanation, I'm taking as 10, but it will not be 10, it will be 9.8. Example, the vertical velocity was also 30. In the beginning, this is a vertical velocity and this was a horizontal. Horizontal remains same. Vertical velocity, what happened? As it will go up, it will decelerate. So when it will decelerate, it means the speed will decrease. So after 1 second, the vertical velocity will be, if I'm, when you solve a question, you will take as 9.8, but for explanation, I'm taking that as 10, acceleration or deceleration. So after 1 second, the speed vertical velocity will be 20. Then after 2 seconds, the vertical velocity will be 10. And after 3 seconds, there will be no vertical velocity. So at the maximum height, the vertical velocity will be 0. But as it come down, move down, the vertical velocity will start to increase. So it will become 10, then it will become 20, and then it will become 30. So vertical velocity changes. As it rises up, it decreases. As it moves down, it will increase. But both acceleration and deceleration will be same, which is due to gravity. Is it clear till now? A projectile motion. Is it clear? The concept of a projectile, the vertical component, it continuously changes, it's accelerate and decelerate, but the horizontal component remain constant. Any doubt till now? So if we sketch a graph for horizontal velocity, and vertical velocity, because it has two components, horizontal and vertical. Horizontal velocity, as you know, it does not change at all because there is no acceleration. So horizontal component, as there is no acceleration, there is no change in the value. So speed will remain. If it's a velocity time graph for horizontal motion, then it will be a horizontal line. But for vertical velocity, as you can see, when we launch a projectile, the vertical velocity is maximum. Then it start to decrease and then again it increases. And because the acceleration is constant, so slope will be constant. So started with the maximum, then it start to decrease. At maximum height it is 0, and then it will be in opposite direction. So we will have a positive velocity and negative velocity. This is a velocity time graph for vertical, and this was a velocity time graph for horizontal. Here the slope is 0, shows it shows no acceleration. Here the slope is constant. Which shows constant acceleration, which is equal to acceleration due to gravity. If we make, this is a velocity time graph, if we want to make a distance time graph or displacement time graph for horizontal displacement and for vertical displacement, so you can see velocity is constant, horizontal velocity is constant. So displacement time graph, the slope represent velocity. So if velocity was constant, it means the slope should be constant. So how I represent a constant slope? So it will be a straight line. So distance time graph, it will be a straight line which shows that there is a constant slope or constant speed. The slope is constant, so speed is also constant. But for vertical displacement, you can see first the velocity is decreasing and then velocity increase. So slope should decrease and then slope increases because it's having two motion. It's going up and then coming down. When it is going up, the vertical velocity is decreasing. So when it is going up, the vertical velocity is decreasing. So means the slope should decrease. And then when it is coming down, the vertical velocity is increasing. It means the slope should increase. So how we represent a slope decrease and the slope increase for a displacement time? And you can see it rises and then it returns. So displacement increases and then the displacement decrease. So this part, when it reaches the top and then it return back. So this will be a distance or displacement time graph for vertical and for horizontal. And for a projectile, as a projectile move, travel, so the distance, the horizontal distance, the maximum horizontal distance traveled by the projectile, that's called a range. And the vertical displacement, the maximum vertical displacement is known as the height reached by the projectile. And the range is maximum if the launching angle is 45. So if we launch a projectile with an angle of 45, it will have a maximum range. But if we change the angle, then the range will start to decrease. So basically, if you have a projectile and you launch a projectile with an angle of, with the same speed, speed is not changing, you launch with the angle of 45. So at 45, it will have the maximum range. But if I increase the angle more than 45, like example, I made it 60 with the same speed, but the launching angle is 60. So if we increase the launching angle, what we will observe? We'll observe the range will decrease. Same way, if we make it 30, So at 30 also, the range will be same as what is the range at 60. So basically at 45, the range will be maximum. If it is like, if we add 15 more, so 45 plus 15, that makes 60. And if we subtract 15 from this, 45 minus 15, that's equal to 30. So if we add the same angle from 45, add and subtract. So at the angles, like if we add 15 and subtract 15, so we get angle 60 and 30. So range of a projectile will be same at 60 and 30. The vertical heights will be different, but the range will be same. But the maximum range when the angle, the launching angle is 45. So whenever you're solving a question related to a projectile for horizontal motion, there is no acceleration. So we can use the formula. If there is no acceleration, we can use the formula speed is equals to distance divided by time. But for vertical motion, because there is acceleration, which is a constant due to gravity, acceleration or deceleration, so what we use equation of the motion. And what are the equations of the motion? The four equations of the motion. We have first v is equals to u plus at. Then we have s is equals to ut plus half at square. Then we have 2as equal v square minus u square, or s is equals to u plus v divided by 2 multiplied by t. So these are the four equations of motion. If we are finding anything related to vertical component, we'll use equation of motion. If we are finding anything related to horizontal component, we will use a simple formula. Speed is equals to distance divided by time. So a projectile motion, I'll share another link for the session and discuss the question related to projectile. So a projectile motion in a two-dimension motion is a projectile motion. Horizontally, there is no acceleration. Vertically, it accelerates and decelerates, which is due to gravity. The vertical component changes throughout the motion, but horizontal component remain unchanged. So if we make a velocity time graph for horizontal, it will be constant, where vertical velocity, if we sketch, it will be maximum in the beginning and it start to decrease and eventually it will increase. This is a displacement time graph. The horizontal displacement continue to increase, but the vertical displacement will first it increases and then it decreases. The horizontal distance traveled by the projectile is known as the range, and the vertical distance is known as the height. The range is maximum when the launching angle is 45. If it's more than or less than 45, then the range will decrease. And we'll solve questions now. If we need a horizontal component, if you need a for horizontal motion, there is no acceleration, so speed is distance over time. For vertical motion, there is a constant acceleration or deceleration. So we'll use equations of the motion.